Oh, let's take a look at number 942. What is the average rate of change of the function g of x equals 6 minus 2x over the interval 2 to 6? Always need to be writing g of 6 minus g of 2 over 6 minus 2. That is our average rate of change. G of 6, sometimes we want to calculate. If I put a 6 in here, I get 6 minus 12, which would be negative 6. G of 2 should be 6 minus 4 would be 2 over 6 minus 2, which gets us negative 8 over 4. So my average rate of change from 2 to 6 is negative 2. What about over the interval from 5 to 7? Right, g of 7 minus g of 5 over 7 minus 5. G of 7, 6 minus 14 is negative 8. G of 5, 6 minus 10 is negative 4 over 7 minus 5. Negative 8 plus 4 is negative 4. 7 minus 5, 2 is negative 2. We end up with the same average rate of change on this function, negative 2 and negative 2, from 2 to 6 and from 5 to 7. Two different intervals. So CS, do you think it's true that g of x will have a constant average rate of change over any interval? Let's think back. What does this function look like? 6 minus 2x would have an x-intercept of 6 and a slope of negative 2. What should the average rate of change be over the entire thing? Down 2 over 1. Down 2 over 1. It doesn't matter what triangle I draw. It's always going to go down 2 over 1 in that ratio. Prove your answer. That's fun. By doing g of x from a to b. So what does that look like? G of x is still 6 minus 2x. G of, and now we want to do it from a to b. So let's write g of b minus g of a over b minus a. What's g of b? 6 minus 2b minus 6 minus 2a over b minus a. If I go ahead and simplify that numerator, 6 minus 2b minus 6 plus 2a, distribute the negative sign. The 6's go away. Keep it over b minus a, good algebra there. And I've got this negative 2b plus 2a over b minus a. We've got to be getting closer. I'm going to come over here with that. They've got a 2 in common. If I factor the 2 out, and actually if I factor the negative 2 out, because we know that's where we want to be going, I end up with b minus a over b minus a. If these go away, I'm left with a constant average rate of change of negative 2. And we've proved it. Sweet.